Quadratic graph features. You have a vertex turning point. So the highest and the lowest point on the parabola depend on the direction of the graph. So to find the vertex, you can use a vertex formula, use x equal negative b over 2a to find the x coordinate. Then you substitute back into the equation they give you, which is s squared, whatever they give you, to find the y value. Or you can use complete the square to rewrite the equation in vertex form, where y is equal a bracket x minus h all square plus k, and the vertex is the h and the k. Graphing, or you can plot the graph and identify the turning point visually.
1. As in this example, our first step is to find half of the coefficient of the x term and square it. Half of -6 is -3, and -3 squared equals 9. Then, we add this value to the variable terms to complete the square. Remember, every time you complete the square, you are creating a perfect square trinomial. So, this is now a perfect square trinomial. Note that, since we add 9 to complete the square, we must also subtract 9 to maintain the equation value. Adding and subtracting the same number resulting in 0 ensures the equation's value remains unchanged. The next step is to rewrite the perfect square trinomial as a binomial square, which will be x minus 3 squared. The number in the binomial always corresponds to half of the coefficient of the x term in the perfect square trinomial. 13 minus 9 equals 4.
So that is the answer they give you, y equal x minus 3 all square plus 4. And this is a completing the square method when you want to put it in the vertex form. Second, axis of symmetry. A vertical line that passes through the vertex, dividing the parabola into two symmetric halves, mean equal parts. Or you can find it, you can use a vertex formula, which is x equal minus b over 2a. Or from the vertex formula, you can look at the axis of symmetry, where is x equal h. And then if you on the graph trying to find the axis of symmetry, you can locate the x coordinate of the vertex, and this is the equation of the axis. Number 3, x-intercept roots are zeros. So the point where the parabola crosses the x-axis, y equals 0. So you're going to equate that function they give you equals 0. And how you can find the x-intercept is, you can use a quadratic formula, but you must identify all the a, the b, and the c. A is the x squared coefficient, b is the coefficient of x, and c is the number that stands by itself. Or if you're good at algebra, you can use factorizing method, where x minus the number equals 0. And then afterwards, to use a factorizing method, you have to multiply the 2n number, and from that you find the factor of that number to substitute into bracket to factorize it. So that is a factorization method. If you're trying to interpret from the graph, you can plot the graph, identify where it crosses the x-axis, where it touches the x-axis, that is the x-intercept. Y-intercept, the point where the parabola crosses the x-axis as x equals 0. So the y-intercept is where you substitute x equals 0 into the equation to find y, and that's always leave the constant, and the number that stands by itself in the function, that is the x-intercept. If you're going to interpret it from the graph, you plot the graph and identify where it crosses or touch the x-axis, so that is the x-intercept, the y-intercept, I must say. Number 5, direction of opening, meaning that whether the parabola is open upward, you know that is x squared. If it downward, like it's sad, it is a negative x squared. So as you see the graph there, and you can check the coefficient of the x squared term, which if it is negative, you know it is gonna be sad. If it is positive, it's smiling. So the minimum and the maximum value. The y value of the vertex. So if you have where the vertex, you see the y value of the vertex is the minimum or maximum value. So how to find it? From the vertex formula, you can substitute x equal minus b over 2a into the equation to find y, and you find a minimum value. But if you're using a vertex, if you have the formula, we have h and k, where k is the y coordinate, and it is the minimum and the maximum value. If you're going to graph it, just identify the y coordinate of the vertex. All right, let us practice. So here is a video, and you
determine whether the parabola opens upward or downward. For a quadratic function in standard form, if a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downward. For our function, a is 1, which is greater than 0, so the parabola opens upward. Next, find the axis of symmetry, which is a vertical line that divides the parabola into two equal halves. The formula for the axis of symmetry is x equals negative b over 2a. For our function, a is 1, b is negative 4. Substitute these values into the formula. This simplifies to 2, right? Therefore, the axis of symmetry is the vertical line x equals 2. Next, find the vertex. The vertex lies on the axis of symmetry. So, its x-coordinate is the same as the axis of symmetry. To find its y-coordinate, substitute its x-coordinate back into the original function. This simplifies to negative 9. Therefore, the vertex is the point 2, negative 9. Next, find the y-intercept. The y-intercept occurs when x equals 0. So, set x to 0 and solve for y. This simplifies to negative 5. Therefore, the y-intercept is the point 0, negative 5. Next, find the x-intercepts. The x-intercepts occur when y equals 0. So, set y to 0 and solve for x. Let's use the factoring method. We need to find two numbers that multiply to give negative 5 and add up to negative 4. We know that 1 times 5 equals 5. But if we make 5 negative, they multiply to negative 5 and also add up to negative 4, right? Therefore, when we factor this quadratic equation, it becomes x plus 1 times x minus 5. Next, set each factor equal to 0 and solve for x. Solving the first equation, we find that x equals negative 1. Solving the second equation, we find that x equals 5. Therefore, the x-intercepts are the points negative 1, 0 and 5, 0. To plot them on the graph. The axis of symmetry is the vertical line x equals 2. The vertex is the point 2, negative 9. The y-intercept is the point 0, negative 5. The x-intercepts are the points negative 1, 0 and 5, 0. Now we add one final point, which is symmetric to the y-intercept across the axis of symmetry. Notice that the y-intercept is 2 units to the left of the axis of symmetry. And remember, the axis of symmetry divides the parabola into two equal halves. So, a point 2 units to the right of the axis of symmetry is also on the parabola. This point is 4, negative 5, right? Finally, connect these 5 points to plot a parabola opening upward.
You might say, on the grid, draw the graph with equation y equals x squared plus 2x plus 3 for x values between negative 4 and 2. Usually, the first part of this question will involve completing a table of values. And often, some of those values are already completed for you. We just need to fill in the rest. And of course, you'll be given a grid to draw this graph on. To complete the table, we're going to need to use this equation here. The way I like to do this is to write out the equation again, but then replace all of the x's with brackets. So let's replace the x on the x squared with a bracket, so it's now bracket squared. And let's replace the x on the 2x with a bracket, so it's now 2 bracket. Then all we need to do is substitute in the x values to get the corresponding y values. We're going to start at the left-hand side of the table here, where x is equal to -4. So we're going to place -4 inside each of those brackets. So it goes inside this bracket, and it also goes inside this bracket. Then we just need to work this out, and it will tell us the corresponding y value. Now you may be lucky and this could come up in a calculator paper, in which case you could just type exactly this into your calculator. But this topic could, and has in the past, come up on paper 1, so you may not have a calculator and have to work it out yourself. Let's assume we don't have a calculator for this question. So we have y equals, and then we'll look at -4 squared. This means -4 multiplied by itself, and when you multiply two negatives, the result will be positive. So -4 multiplied by -4 is positive 16. Now we can look at two lots of -4, two lots of -4 is -8, and then at the end we just have +3, so +3. Then if we just do 16 subtract 8, which is 8, and then add 3 to that, we get 11, so y will be 11. So we found that when x is equal to -4, y is equal to 11, so we can put 11 into the table. Now let's move along and have a look at the next one. So this time when x is equal to -3. We do this in exactly the same way, we put -3's inside the brackets, and work this one out. So we've got y equals -3 squared, which will be positive 9, two lots of -3 will be -6, and then +3 at the end, so +3. 9 take away 6 is 3, and if you add 3 to that, you get 6. So when x is -3, y is 6, so we can add that to the table. Now let's move along and have a look at when x is -2. So if x is -2, we put -2 inside the brackets. So y equals -2 squared, which is positive 4, plus two lots of -2, which is -4, and then +3, so +3. 4 take away 4 is 0, and then if we add 3 to that, we get 3, so y will be 3. So when x is -2, y is 3, so we put 3 into the table. Now the next two values have actually been done for us, so we can move all the way along to when x is equal to 1. So we put 1 inside those brackets. Y equals 1 squared, which is just 1, plus two lots of 1, and two lots of 1 is 2, and then +3. So we've just got 1 plus 2 plus 3, which is 6. So we put 6 inside the table. Now we're ready to turn this into a graph. To do this, we're going to plot each pair of x and y values as a coordinate. So the first pair is when x is -4 and y is 11. That's the coordinate -4, 11. If we plotted that, it would go here. Then we do -3, 6, which goes here, -2, 3, which is here, -1, 2, which is here, 0, 3, which is here, 1, 6, which goes here, and 2, 11, which goes here. Now to complete this question, we need to join each of these crosses together, and you might be tempted to get a ruler and join them up with straight lines like this, but this will not get you full marks. This graph is a quadratic graph, and it should be a nice smooth curve, so we would draw it something like this instead. It's already been drawn, and ask some questions about it. So for this one, here is a graph of y equals x squared minus 6x plus 5, and we're going to answer the following questions. Write down the y-intercept of the graph. So the y-intercept is where the graph crosses the y-axis. The y-axis is the vertical one labelled y, so we can see the graph crosses it here. That's at point 5, so the answer to the question, the y-intercept, is 5. Sometimes they may ask you this as a coordinate, and if it asks it as a coordinate, it would be 0, 5. For part B, it says write down the coordinates of the turning point. The turning point of the graph is this point right down here at the bottom, where the graph turns. Its coordinates are 3 for the x-coordinate and -4 for the y-coordinate, so the answer for the turning point is 3, -4. Part C says, write down the roots of x squared minus 6x plus 5 equals 0. A root is just another name for the solution to an equation. Notice how the left-hand side of this equation, x squared takes 6x plus 5, is the same as the equation for the graph we drew. The only difference being that our equation says equals 0, whereas the graph said y equals. So what we're really trying to do when we solve this equation is find the x values that give a y value of 0. If we look at the graph that's been drawn for us, y will be equal to 0 when we're on the x-axis, since the y-coordinate is 0 there. There are 2 points where the graph crosses the x-axis. That's this one here and this one here. So when x is equal to 1 and x is equal to 5, y is equal to 0. This means that x equals 1 and x equals 5 are the solutions to that equation, which we call the roots. So for the answer for this one, we would write x equals 1, that's the first root, and also x equals 5, that's the second root. So to find the roots of this equation, since it matches the equation of the graph, we just find where the graph crosses the x-axis. And for the final part of this question, we need to write down the equation of the line of symmetry. All quadratic graphs have a line of symmetry that goes through the turning point. So to find the equation of the line of symmetry, I'm going to draw on the line of symmetry first. So it's a vertical line that goes like this through the turning point. All vertical lines are of the form x equals and then some number, that number being where it crosses the x-axis. This line of symmetry crosses the x-axis at the point 3, so the equation is x equals 3. So for the answer for this one, we write x equals 3. Let's try another example like this.